Right. Hello again, everyone. It's of course Joshua Gunnett here, and I'm here to show you all how to utilize the new Jointbreaker system, especially the full damage system, because the full damage system it can be a bit finicky to those that aren't kind of new to this anyway, because I know how people are new to coding, programming, and building robots. So I'm going to give you a little rundown of how it works, just so that people who host competitions and the like know just how full damage works. So essentially, how it works is it works in about, I'd say, three parts. The three parts being the full damage block, the full damage checker, the height checker, which is named new full damage block in a model, and damage C. You can read the README, by the way. It gives the basic rundown, but of course I was suggested to make a video about it, so I'm doing this anyway. So here's what you do, how you implement it, because the implementation requires a fair bit of work between both roboteers and competition hosts. So what the roboteers have to do is they have to take their full damage block. It is named safe, so of course damage Jointbreaker or Jointbreakers can't damage it, and it can't ever be affected by damage. So it's all cool. You take this little safe part, which is only 0.1 by 0.1 by 0.1. That's the recommended size. It doesn't need to be massive. It just needs to be tiny and be placed within the center of your robot. So I'm just going to take this durable part here and just, find the rough center of this bit here. I think it's about 0.5, yeah, 0.05. Yeah, just place it just somewhere in the middle here, and then you then just weld this safe part, or the height checker, to any part, like as many parts as you want within the shell, because the general idea is I want this full damage checker to be attached to your robot for as long as possible, and ideally it should be attached to all the parts your wheels are attached to, any parts your weapons are attached to, and then any sort of grounding or important attachment parts to keep the bot together. So that way, if your robot just gets completely annihilated in the arena, then the full damage part breaks off anyway. And because the full damage must be at least probably the last thing that needs to break off of the robot. So like, it should only really break off when your robot is technically speaking inoperable. So there we are. You also so once you've got all the bits together, once you've welded these the safe part and the durable parts all together to all the bits you needed, you sort of put them together. You put them together into your model here, and then ensure that the damage C is in the robot model. So if I name this robot, it should damage C, which is the number value, should remain here, because that's the part that's going to be saving how much damage your robot takes when it reaches a certain height. So make sure it's put there. Do not put it in a separate model. It has to be here. Even if you've got more than one model inside of this robot, it has to be this, like, the parent of this value should be the model that holds everything together, if that makes sense. If it doesn't, ask your mother. Anyway, so what you do is you go into the, once you put it all together, you need to ask the competition host what are the increments of height, or milestones of height, for the arena, because not every arena that is built is going to be built at like base plate level, so it's not going to be at 0 or 1 Y value. Therefore, the competition host has to outline the increments. What I mean by increments is if we go into the full damage script here, I'm going to open up a bit. These are all the. This is just essentially how it works. It's a continuous while true do loop that continually checks the current Y position of the safe part. As you can see here, it also links back to damage C, which will be there. So if you just do like we just name that robot, it now knows exactly where damage C is. Current Y is assigned later. These are local booleans that will pardon me. These booleans here, they check to see if someone has reached a certain height. And what happens is that they are there to ensure that when a robot falls back down, they're not going back through the increments. So when someone passes 2 increments and then fall back down, they're not immediately going to go back to be reset by the first increment. It's always the higher increment always takes priority over the lower ones, and that's how it's been made. So what happens, of course, is that the current Y value, it just tracks the continuous Y position of the safe part. Current Y value will equal current Y. Current Y. So that's the bit here. So that's what this current Y value. That's what's going to be referenced by the yeah, this was referenced by the script here to check. I know there probably is a much more simpler way to just reference current Y, because these 2 bits here are probably a bit egregious. Since I probably can just reference the part directly for the current Y value. But I've done it this way anyway, because that's how I've worked it. But I'll probably later down the line fix it up to make it more simpler, less lines of code and all. After this, robot name.value equals robot.name. We're going to get to that in a moment. We're going to skip past this bit because this bit needs to be first. This part always needs to be first. So I'll skip this part from a bit. So after waiting 0.1 of a second, we then go to if current value val.value equals 20, and current value is less than 20 or greater than 20 but less than 40, and check 1 equals false and check 2 does not equal true and check 3 doesn't equal true, then check 1 equals true. That's essentially saying if the other ones above me, if the other increments above me are not true, and the check 1 isn't false, we get to the first increment, damage C's value is set to 4, and we print that in the log just to tell us that it's working. We then go to current val.value number 2. This is the second increment, increases the damage, does the same thing on the third increment, maximum damage possible, which is 8. And then the last bit, if the value is less than or equal to 19, this is below, of course, the first increment. It then resets it all, so that way if a robot gets flipped back up again through the increments, it's a perfect loop. Because at that point, the robot will be coming down when we get to this bit. And then, of course, we now loop back up to this section here. If damage C.value doesn't equal 0, and current Y value is less than or equal to 19, we then find the full damage block. We then go to the name checker inside that block and then assign that value as a robot name.value. Of course, this bit here is a string. It's a string value. And what this would do is it will save the name of the model of the name of the model, and then it will send that to the full damage block. Once it's set to the full damage block will save it in its name checker. And then, of course, it will then print to us name is sent. So let's go for the motions here. Robot's flipped up. It reaches the highest increment possible, and then it comes rocketing back down towards the ground, strikes the ground. The ground will, of course, have the full damage block, or the full damage sort of checker implemented within it, or on top of it, however you want to do it. I recommend keeping invisible, but whenever you want to test out its collisions and that, it's got to have no collisions whatsoever, well, no physical collisions, so it can collide false, and I recommend invisible. You can turn it translucent if you want to when you're doing your testing, but yeah, essentially in this checker script here, there are a lot of lines. Of course, it's a bit messy, but how it essentially works is that it references the name checker, the smoke fella. If you've seen the earlier Jointbreaker video where I've demonstrated the spinner Jointbreaker, then this is just all essentially that spinner Jointbreaker bit here. So damage C will of course be hit.parent find first child damage C. So what that means is that once it strikes a part, it then goes up one in the model, and hopefully it finds damage C within that bit here, as we've assigned a local variable. And if damage C doesn't equal nil, then we go with the first option, and then we do all of these bits here. Thumbs up. So essentially, after that though, once the damage has been done in